Hello everyone, welcome back again, and in this video we are going to learn about operators in Java. So create a file and call it operators.java or whatever you want, and let's get started. Java provides many types of operators which can be used according to the need, and they are classified based on the functionality they provide. Some of the types are, let me show you. We have the arithmetic operators, we have the unary operators, we have assignment, relational, logical, ternary, bitwise, and shift operators. In this video, we are going to cover all of them one by one, starting with the arithmetic operator. So create a class and add a main method. Let's get started. Arithmetic operators. They are used to perform simple arithmetic operation on primitive data types, and they include multiplication, division, we have modulus, we have addition, and then subtraction. To use them, let's take an example of two numbers. Let's initialize x, give it 10, then y, give it 20, like that. To perform the arithmetic operation, you can do s out x plus y for addition. For division, you can do x divided by y. Multiplication, you can do x multiplied by y. And for subtraction, you can do x minus y. And for modulus, you can do x modulus y. Something to note is that when you divide 10 divided by 20, it will give us 0.5, and given that this is an integer, this will be truncated, so the result will be 0. If you want to print the decimal value of it, you have to convert the denominator to a double, and to do that you can do this double result, and you can say inside the bracket x divided by, you typecast y to a double like this. So let's run this code and see the result. Let's clear the screen, that, then run it like that. When you do that, you can see here added, then when we divided, the answer is 0 because it was truncated. But when we typecasted the y to a double, we got the result in decimal point. Then multiplication, the subtraction, and the modulus. The modulus is like working with a remainder. For example, when you do 10 divided by 20, the remainder is 10. So here the result is 10. And that was the arithmetic operators. Next we have unary operators, and for the unary operators need only one operand. They are used to increment, decrement, or negate a value. They include the negative, we have the positive, or the minus and plus, we have the pre and post increment, and pre and post decrement, like that. For the positive value, it can also be used in something called unary numeric promotion, where you perform automatic conversion to integer when the type of its operand is the byte, character, or short. For example, you can have a character, call it a, give it a value a like that, then have a byte b and give it a value 5, short say and give it a value 5 too. Then have an integer here d. This we want to add all of this to show you what I mean when I say unary numeric promotion. So it will convert all of these values or variables data type into an integer. So you take a, b, then c, like that. So the representative of a in decimal value is 96, I think 97 there. Then you can add 5 and 5, that will give us 107. You can print this out, say the value of the integer is, and print it there. Let's run this code by running that, and you can see this is the value. So that is how you use the plus or the positive operator here to perform unary numeric promotion. Next we have the increment and decrement. So for the pre-increment, Let's take an example of int x, give it 5 to perform pre-increment. This is how it works. You can do that. So what happens here is that the value is used in operation or computing the result, and then it is used. So that means we will first increment x and then print it out. So the result here will be 6, like that. For the post increment, it is different because we first use x to compute the result and then increment it. And because x is 6, so we'll first print 6 and then increment it, like that. This is how pre and post increment work, and it is the same with the decrement. So for the decrement, you use the minus sign here. Because x is 5, we'll first minus it and then print it. We will print 4. Then here we'll first print that 4 and then we will decrement it. So here it is decrement, like that. So here the result will be 4, same as here, because we will first print it and then decrement it. When you try to print x again here, the answer will be 3. We'll have 4, 4 and 3. Let's do it. When you do that, you can see the result. Those were the unary operator. There's another one I forgot to show you called the logical not, shown by this exclamation sign, and it is used for inverting Boolean values. For example, you might have a Boolean, let's say Boolean A, and you can give it true, like that. Then to use the logical not, you just say not A. Not A means that if A is true, we want to print it as false. So when you run it, you can see we inverted A from true to false. And that is how you use the logical not. Next, we have the assignment operator, and it is used in assigning value to a variable. The general format is like this. Then you assign a value, and it has an associativity of right to left. That means that the value given on the right hand side will be assigned to the variable on the left, and in that case the right hand side value must be declared before using it, or must be a constant. For example, like a 10. In many cases, the assignment operator can be combined with other operators to build a shorter version of statement called a compound statement. So let's see a few examples of a compound statement. Let's say you have an integer x here. You can give it 10, and you want to perform an operation, maybe x is equals to x plus 10. Instead of writing this longer version like this, you can use a shorter version, which is x plus is equals to 10. This is the same as this one, and same goes to when you try to do x divide is equals to 10, or x multiply is equals to 10, or another variable. Maybe you have int y here, then you can assign something like 20 and come and say x multiply is equals to y, which means x is equals to x multiplied by y. You can combine other operators like the modulo and the negative. These are examples of compound statements, and that is how you use assignment operator. So you can print them out to see the result. The next, we are going to talk about relational operators. And for the relational operators, they are used to check for relations like equity, greater than, less than, and they return result after comparison, and are extensively used in loops and if-else statements. The general format is a variable, then we have the relation or the relation operator, and then a value. We are comparing this value to this variable. Some of them, all the relational operators, are the equal sign represented by double equals. Then we have the not equal. We have the less than. Move this one down there. We have the less than or equal to. We have the greater than, and we also have the greater than or equal to. Let's see how they work. For example, we can have two variables here. Int x can give it 10, then y give it 20, like that. We will start with the equal sign. We can do s out x equals to y. So this one will return false. And you can do the same to the others. Or you can pause the video and write this one out. So here, when we compare x and y, x is definitely not equal to y. So this one return false. This one is true because x is not equal to y. X is less than y, true. Then this one is true. X is not greater than y, and x is not greater or equals to y. We can run our code like that. And as you can see here on the result, we have false, true, 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 then false, false. That is how you use the relational operators. The next operators on our list is logical operators. And for the logical operators, they are used to perform logical AND and logical OR operation. That is a function similar to the AND gate in digital electronics and OR gate also in digital electronics. Some of the operators or conditional logical operators include the double AND, which represent AND. We have the double OR here, represented by two pipes. Then we have the logical NOT. To use them, we can take two variables. We can say a boolean a, can assign it to true. Then we can have b here like that, assign it to false. Then we can print them out. So we can say b and a, and this one will result to false. And when I said short circuiting effect is that when this one results to false, this condition is not checked. So when b returns false, a is not checked, because for logical AND, both conditions must be true. And if this one is false, there is no need to check for this one because the overall result is false. For logical OR, do a or b, which will return true, because for OR it checks if either of these two conditions or two variables is true, and because a is true, that one will return true. Then we have the logical NOT, and we can do a, which we worked with this earlier, so this one will return false again because a is true, and it will invert it to false. Let's run our code like that, and you can see the result here. See, that is how you use the logical operators. And the next operators on our list will be the ternary operator. And for the ternary operator, it is a shorthand version of an if-else statement. It has three operands, and that is why it's called ternary. The general format is like this. We have the condition. Then if that condition results true, you can execute the code that you put there. If that condition is false, you execute the code that is between or that is after this colon here. A good example is, let's create a boolean here and give it value true, then create a string to check if a is a true, like that. Is a true, so we do that. If a is true, then you will assign a true to that string, but if a is not true, you will say a is false. Then you can print that string there, and because a is true here, this will be executed. The code or the value that you put after this question mark, but if a is false, this will be executed and this one will be skipped. Let's run our code like that, and you can see a is true. When you change this one to false, then run our code again, the answer will be a is false. That is how you use ternary operator. You can make them complicated the more you use them, because they are very widely used, especially in building application and checking conditions. If you don't want to use if-else statement, you can use these ternary operators. The next operators on the list will be the bitwise. For the bitwise operator, they are used to perform the manipulation of individual bits of a number. They can be used with any integer, and they can also be used when performing update and query operation in the binary index tree of data structures. And they include the bitwise AND, represented by a single ampersand. We have the OR, represented by a single pipe. We have the XOR, or bitwise XOR. Then we have the bitwise complement. Let's take an example of a value like 10, the binary representation of 10. Then let's start by performing an operation with a number like 5. So we'll have, that is the binary representation of 5. When we perform the AND bitwise operation here, it checks if these two numbers here are 1. If they are 1, it will result to 1. But if they are different, it will result to 0. It comes and check 0 and 1. They're different, so that one is 0, 1 and 0, 0, 0 and 1, 0. But if we had something like 1 here, 1 and 1 will be 1. Okay, 0 and 0, that will be 0, not 1. For logical OR, it will be different. It comes and check if one of them is 1. For the first one, it will be 1. The other one, there is no 1, so it will return 0, then 1, then 1, like that. For the logical XOR, it returns 1 if the corresponding bits are different. For example, here, these are the same, so it will return 0. These are the same, it will return 0. Then these are different, so it returned 1 there. These are different, 1 there. So that was XOR. And for the complement, let's use 1 operand here. When you do complement of 10 like this, it will invert these bits 1 to 0, 0 to 1. That is the bitwise complement. But don't worry about this very much, because they are rarely used in daily occasions. Lastly, we have the shift operator, like that. And for the shift operators, they are used to shift bits of a number left or right, thereby multiplying or dividing the number by 2 respectively. The general format is like this. You have your number there, then the operator itself, and the number of places you want to shift. The operators inside the shift operators include the left shift, represented by two left angular brackets. We have the signed right shift, represented also by 2 right angular bracket, and we have the unsigned right shift, represented by 3 angular brackets. So for the left shift, let's take an example of an 8-bit representation of 10, which we will represent it like that. So that is 10. And when we perform left shift, let's start with the left shift. You can do 10 once. And when you are doing a left shift, this is multiplication, okay? And this is like saying 10 multiplied by 2 raised to power of 1. If we have 3 here, we will change this one to 3, okay? Let's start with the simple one, that is 1. When we shift these bits to the left, this one will come here, this one will come here, this 0 will come here, and this 0 will come, and this will be left void, and we will fill it with 0. And the result will be like this: 1, then 0, 0, 0, like that. And this is the representation of, or binary representation of 20. When we perform right shift here, that is like doing division, okay? The right shift here will be division, and instead of moving or shifting the bits to the right, left, it will shift them to the right, like this one here. Here the answer will be 1, 2, 3, 4, then 1, then 1, 0, 1. Okay, and this is the representation or binary representation of 5. The difference between the signed shift and the unsigned shift is that for the signed shift, it respects the sign number. If we have the negative representation of 10 like that, I think that is how you represent 10. That is minus 10. If you have something like that, then perform the right shift of this one once like that. This will be like saying negative 10 divided by 2, right, raised to the power of 1. You see here the other bits are filled with 1 because the first number there is 1. This one will be filled with 1, then 1, then 1 0 1 like that. Okay, that is representation of negative 5. But for the right shift, this one unsigned right shift, it does not respect the sign number. It fills everything with 0. Here it will be 0 0 0 1 0, no, 0 1 0 1 like that. Okay, so this will result into something else. Let's see it in action. For example, let's create a number here, integer a, give it something like 10, then do right shift a, right shift 10 once. This will give us 5. Let's run it. Do that, you see 5. And if it is a negative, here, it will give us negative 5 like this. But if we do unsigned right shift, I told you for the unsigned right shift, it does not respect the leftmost bit of the signed binary here. It fills everything with 0. So the result here will be something very different and not 5. So let's do it. You do that, you can see the result that you get totally different. That is the difference between signed shift and the unsigned shift. And those are the operators used in Java. In the next video, we are going to talk about flow control in Java, where we will work with if statement and else statement. See you in the next video.